Example 7. Find the real solutions of the equation 3x cubed minus x squared minus 21x plus 7 equals 0. So we know that real solutions of this equation set to 0 are the same as finding the real zeros of the function f of x equals 3x cubed minus x squared minus 21x plus 7. So this is just another way of asking. So we need to find the real zeros of the function f of x equals 3x cubed minus x squared minus 21x plus 7. So we'll go through our steps to finding real zeros. Our first step is to look at the degree to determine the maximum number of real zeros. So we have a degree 3. So we know we're going to have a max of 3 real zeros. Second step, let's find our possible rational zeros using the rational zeros theorem. So we're going to list our p-values, which are going to be factors of the constant, which in this case is 7. So we want plus or minus 1 and 7. Then q is going to be factors of the leading coefficient, which in this case is 3. So we want our plus or minus 1 and 3. So our p over q combinations will be our possible rational zeros. So we want 1 over 1 and 1 over 3. So 1, 1/3, 7 over 1, 7 over 3. So we've got 7 and 7/3. So this is our list of possible rational zeros. If we have any rational zeros, they have to be on this list. So these are our possible rational zeros. Okay, so third step, we're going to graph on our calculator. So we enter the function 3x cubed minus x squared minus 21x plus 7. And then I'm graphing on a standard viewing window. And we can see it looks like there's 3 x-intercepts, which makes sense. We have a degree 3. We could have up to 3 real zeros. So it looks like it has exactly 3 real zeros. Now we just need to determine exactly what they are and verify them algebraically. So let's look at our list. We've got possibilities plus or minus 1, 1/3, 7, and 7/3. So it certainly doesn't look like 1 is going to work there. It looks like this could possibly be a 1/3. Over here, this looks about 1, 2, between 2 and 3. So that could possibly be the 7/3. And over here, it's between -2 and -3. That could be a possibly negative 7/3. But we want to check for sure. So let's calculate our zeros. So let's calculate, and we'll do the leftmost zero first. So I'm going to arrow over a little bit left of where that 0, so it looks like it occurs somewhere between -2 and -3, so just scroll over there. So a little bit left, and hit enter for your left bound, and then scroll a little bit to the right, and hit enter for your right bound, and then hit enter one more time. So it looks like we're going to get about -2.6, -2.65 if we round it. So if we want to make a little sketch, so it looks like we got one of them is about -2.6. Now 7/3 though, that's 2 1/3, so that's about 2.3. So we know that this isn't actually the 7/3. So this is a different 0. So this -2.6 actually does not appear on this list. So that means it's not rational, which it's obviously not, the -2.6 with that decimal that doesn't terminate and doesn't repeat. Okay, so now let's look at our other zeros. Let's calculate the other ones. So I'm going to move my cursor a little bit over here. So it looks like that second one occurs between 0 and 1. So I'll hit enter here for my left boundary, and then arrow over just a little bit to the right, and hit enter one more time. And that looks like the 0.3 repeating, so that is our 1/3. So we know that our second 0 here is exactly that 1/3. So that's on our list of possible rational zeros. And then our last one, if we calculate, so move that cursor over a little bit to the left, so it looks like it's between 2 and 3, so just get your cursor somewhere there, enter, and then move it a little to the right, enter, and then hit enter one more time, and then that's your 0. This is a positive 2.6. So this is irrational. You can see that decimal that doesn't terminate and doesn't repeat. So these are irrational zeros. This 2.6 approximately and the negative 2.6 approximately, those are the irrational zeros, and that's why they did not appear on our list. So let's just make a sketch here though. So about 2.6. And then let's just get that approximate shape. So we're increasing and we turn around. Okay, so we see 3 x-intercepts. So we know that that means we have 3 real zeros. Now let's start with the one that's on our list, the 1/3. That'll be easiest to verify algebraically. So if we want to show that 1/3 is a zero of this function, I want to show that x minus 1/3 is a factor. So I'm going to put my 1/3 in my upper left, and then I'm going to list the coefficients of my dividend of that polynomial function, 3, -1, -21, and 7. So let's perform this synthetic division. Bring down the 3. 3 times a third is 1. -1 and 1 is 0. 0 times a third is 0. -21 and 0 is -21. -21 times a third is -7. 7 and -7 give us 0. So we got a remainder of 0 when we divided by x minus 1/3. So we can break down our polynomial now into factors, x minus 1/3, and then our depressed polynomial, our coefficients here of our answer. We started with the cubic, so we know this is going to be squared, 3x squared, and we've got a 0 for the coefficient of x, minus 21. So we just showed here algebraically that 1/3 is a 0 of this function. So now, once we get down to our quadratic, we know we can just factor or use quadratic formula to solve this. So 3x squared minus 21, we know we can factor out a 3, so that'll give us x squared minus 7. Now we know that this x squared minus 7 won't factor because this 7 is not a perfect square. So if this won't factor, we can find the solutions. We can set this to 0 and find the solutions and go backwards and make the factors. So if I set this equal to 0, I'm going to get x squared minus 7 equals 0. Add the 7 over. If I take the square root of both sides, I'm going to get x equals plus or minus radical 7. So these are your remaining 2 zeros. The 1/3 was on our list of rational zeros. Here we verified it. And here's the remaining 2 zeros, and they turned out to be irrational, so they weren't on that list. And if you enter square root of 7 into your calculator, you will see that it is approximately that 2.64, etc., those ones that we saw in the calculator. So this is approximately plus or minus 2.6. So now, when you go to factor, you've got your x minus 1/3, and then we broke down the 3x squared minus 21 into 3 times x squared minus 7. So I'm going to move the 3 out into the front and put the x squared minus 7 here, because when we write these polynomial functions in factored form, we like to write them with integer coefficients, so we want to remove this fraction, and this multiplying the 3 here through here will remove that fraction. So that gives us 3x minus 1 times x squared minus 7. So we found our real solutions are the real zeros. So we found that they are 1/3, radical 7, and negative radical 7. Now, another way to do this problem, if we rewrite our equation, 3x cubed minus x squared minus 21x plus 7 equals 0. If we look at this with the 4 terms, we know if we have 4 or more terms, a method of factoring that could work is grouping. So we could actually try to directly factor this and directly calculate those solutions instead of going through and finding the real zeros. So if we group the first 2 and the second 2, I can factor out an x squared from both of these. So I could take out x squared, and then I'd have 3x minus 1. And then I'll bring down my minus sign in the middle. And then the second 2, I can pull out a 7, and then I'd have 3x minus 1 here. So we can see these two match, the 3x minus 1, so I can factor this by grouping. So this would give us 3x minus 1 times x squared minus 7, and that takes us right down to here. So if we set our 3x minus 1 to 0, we add our 1 over, we're going to get an x value of 1/3. And if we set our x squared minus 7 to 0, add the 7 over, take the square root of both sides, we're going to get that plus and minus radical 7. So if the polynomial factors, you can directly factor it and then set those factors to 0 to get the zeros or the solutions to this equation. But many of them will not factor like this, so that's why we want to have this method in our repertoire as well.